In physics property, we have 8 properties mentioned: force field, collision, cloth, dynamic bend, soft body, fluid, and rigid body. Among all this, first we will see rigid body in detail, and it is very important. This image shows the 4 separate menus: rigid body tab, scene property, rigid body submenu, and rigid body constraint, which together work for the best result. Now, the first question: why to use rigid body constraint physics? For example, in a scene, we have a hollow cube container with a sphere ball. If we wish that this container should fall and then the sphere must come out of it, for this we can use the keyframe or the constraint and it will work. But if we use the rigid body physics, then it will also work. Finally, you can see the difference. The keyframed animation look fake and unnatural, and the second animation look exactly near to the reality. If any object fall, how both the object will interact and react. So for this reason, we use rigid body physics, which is fast and believable. In the viewport, we have set up one scene, that is apple tree and ground. So by the nature and the gravitational force, apple must fall on the ground, and which define the law of gravitation by Newton. So select the apple, go to physics property, select rigid body. The first option you see a rigid body type, that is active and passive. Select active because it is the independent object which going to fall on the land. Right now, ignore all other options, just keep active. Second, select the ground surface. Add rigid body and its type to passive, because it will be static at one place but still has the physics to react with other rigid bodies. Now just press the space button to simulate the physics. Instantly you can see that the apple falls on the ground due to gravity and react to the geometry of the ground. If we remove the rigid body on the ground, then apple will pass through the ground surface. So we need a rigid body as a passive object. So this was the basic principle to apply rigid body physics on the two bodies. Let's explore more options in rigid body physics. First option was the rigid body type, active and passive. Next one is collision. By clicking on collision, you will see some collision shape names. The geometry design look something like this. This option defines the imaginary shape of the object which will follow the two body interaction. For example, in the basketball court, we have set up the rigid bodies on the floor and the ball. After playing the animation, it works. In the collision section, the ball collision set to mesh. Let's change to the cube. Now the box wireframe appear on the ball. As we play the animation, now collision will not be according to the sphere. It will be considered the cube area. In this way, you can try cone, cylinder and other to get a different result. In the most of the case, mesh option work the best for the physics simulation. Collision property can be modified on both active and passive object. In this example, a collision object is cylinder and collision is set to cylindrical. So it perfectly roll on the surface. If you try to change collision type to cube, then it will not work. And due to its cylindrical shape, a collision type cylinder or mesh work perfectly as per the physics. Next in the rigid body is the sensitivity, friction and bounciness. Sensitivity. If you look at this simulation closely, You will notice that the ball is not touching the floor and has no contact with each other, and it does not look nice. We can fix this by adjusting the sensitive value. Go to the rigid body menu. Here you will find the sensitivity. Margin value, which is default 0.04, reset it to 0. Now if you play animation, ball will perfectly touch the floor. And if you increase the value, then the distance of the contact will increase. And now you will notice that the ball is touching the floor, but it is not bouncing. By nature, it must react to the floor and bounce back. Look at the rigid body setting. Here, the bounciness value is 0. So select the ball, set its value to 1, and also select the floor and set its value also 1. Then play. Now the ball bounces to the maximum value. You can adjust the bounciness value to get the desired realistic output. Friction. We have a cylinder with a rigid body applied, also a rigid passive inclined floor. Cylinder roll on the floor due to friction. In the rigid body setting, friction is set to 0.5 for both cylinder and floor. Let's set it to 0 to both cylinder and floor property. Now if you play the animation, the cylinder will slide on the floor and not rolling, because the friction between both cylinder and the surface is set to 0. So by entering the appropriate value, we will get the correct rolling of the object with respect to the physics. Mass of the object. In rigid body, the mass of the object is very much important because it will affect the gravity when it's falling. For example, we have 3 objects on a viewport: a basketball, a heavy weight, and an apple. Now all 3 are different objects and have different physical properties. Mass or weight of the object is mentioned on the right option of the rigid body setting. By default, it is set to 1 kg for all. And mass of an object not mentioned for a passive object. It will be only for the active object. Here you can manually enter the mass of the object. If you want that mass of the object to be calculated automatically, then select the object. In object mode on the top, select object. Here you will find the rigid body submenu. Click on the calculate mass, then you will get the list of a material. Choose your preferred one. For the basketball, let's select rubber. It will display the mass more than the 40 kg. This is because of the dimensions. Look at our dimension property, which is about 0.40 meter. It is much more than the actual one. Now if you change its diameter to the 5 inch and then again calculate the mass, now you will get around 2 kg. So the real world dimension is important to get the perfect mass of the object. So for this example, a sphere at a distance from the cube hit the cube and collision take place. First, add a plane as a floor and apply rigid body passive. Second, add a cube and the sphere at a distance from each other on the space. Apply active to the both rigid body and play the animation. Instantly, sphere and the cube fall on the floor. Now to solve this and hit the sphere to the cube, we will keyframe the sphere location. Select the sphere and in the rigid body setting, enable animated. Then at frame 1, add a location keyframe. Shift to frame 10 and add another location keyframe just before it hit the cube. Now play the animation. This time sphere reached near to the cube but does not hit. And second error, the cube must be at its place steady, but it is falling down. So to keep the cube steady, select it, go to the rigid body setting, look downside. You will find the dynamic option. Expand it. You will see the deactivation. Enable it. And also click start deactivation. This option will keep the rigid body steady up till any other object hit or touch it. Now after it, you will see the cube will be resting in the place. Last error, the sphere to hit. To solve it, we need to add another keyframe. So select the sphere, go to the frame 1, then look at the rigid body. Here we have selected the animated. So at frame 1, click on animated icon. It will insert the keyframe. Then go to the frame 10 and deselect the animated option and add a keyframe. Finally, play the animation. It will work perfectly. Now let's see the logic behind it. The keyframe between 1 to 20, the sphere will move near to the cube. And adding again rigid body keyframe will disable the physics between 1 to 20 and start only after the end of frame 20. Let's see how it affects our simulation. In our scene, the sphere hit the cube and the cube got displaced from its place. Fall down very dramatically, taking a number of rotations. We can control this dynamic rotation. Select the cube. Just in the rigid body setting, in downward you will find dynamic. Expand it. The two options, damping translation and rotation. Now rotation value is set to minimum. Let's increase it to maximum 1. Now it will not rotate and just slide on the space and fall down. Now decrease the value. This time cube take rotation and fall down. In this way, value from 0 to 1, we can control the rotation simulation and it is very useful. Next is the damping translation. Now damping is set to 0.5, which result our simulation work as accepted. But if damping increased to the 1 value, then the cube do not even move from its place. It just rotate steadily at one point. Let's decrease the damping value. Then animation work normally. So damping affect the collision status of object. Freehand animation or simulation. In this example, a rigid body ball falling, and at the same time by moving an object using a mouse you can interact with. To set up, let's have a ball on the space at a height. Apply rigid body, keep it active. Second, a simple plane, add rigid body, keep it passive and click on animation. Before playing the animation, just keep selected the plane. Now press the space button. As the ball falls, you can move your plane. And try to react with the ball. It will just feel like playing a video game. This is the another example showing the rigid body simulation. We have added a curve and given some random shape. Then we have added a sphere with a rigid body active. Then dynamic and animated both selected. Then the sphere is also applied with the follow path constraint with curve. And a group of a cube added with a rigid body applied along with the dynamic deactivation. After playing the simulation, you will get this cool result. In this simulation, a brick wall is applied with the rigid body to all the bricks. Let's see how we can apply physics when object quantity is more than 1. Using a free Blender add-on, extra object, add a brick walls. This brick wall is connected overall and considered as one object. If we add a rigid body to it and play the animation, the brick reacts like a whole one cube, which is physically not correct. To make correct, first we need to separate this brick from each other. So select all in edit mode, right click, click on separate and separate by loose part. Now every part is separate, but still all bricks have a common origin at the bottom. Again select all, go to object and set origin to geometry, which provide origin to all the selected objects. To add a rigid body, select any one of the objects, then set it to active and done, it's working. Now how can we add this rigid body to the multiple object? Yes, we can select one by one and add a rigid body, but this process will be time consuming. So second method, select all, then keep the last active selection to the object which is already has the rigid body applied. It will highlight in a green outline. Go to object property, in rigid body sub menu, click on copy from the active, which means it will apply a rigid body to all the other selected object from the data which is provided to the active select object. Then you can check if all the bricks have the same rigid body and also work in simulation process. Baking simulation. Once we have set up the scene and add a rigid body simulation, then we are ready to render. Before rendering, we can bake this simulation to simplify the rendering process. Baking is nothing but converting simulation to keyframes. In our scene, a box falling from a table. Select the box, go to the object option. In rigid body submenu, click on bake to keyframe. Set the required keyframe length and OK. In a few seconds, you can see that the keyframe added on the timeline. Now it does not depend on the physics and we can change any position or add a new keyframe. Here click on it. First is the gravity and second the rigid body world. Let's see how this affects simulation. We have a simple scene where a group of a cube fall down. Once you set up the scene and play the animation, it will work and look okay. Now on the scene property, go to rigid body world. Here first option is speed. Default is set to 1. If we increase to 4, then the simulation speed will get accelerated. Similarly, if I set it to 0.5, then it will have the super slow motion effect. And also, you will get a different result every time if I change the values. Next, sub-step per frame, which is default 10. A per frame value defines the simulation value, which will help to give the more accurate result. More the number, better the simulation interaction between the object. Same for the solver iteration. The rigid body function affects the render and hardware uses to the peak performance. Make sure to have a good computer setup in order to experiment with this function. Last in the rigid body world is the field weight. Here you will find the big list of physics properties, which we'll discuss in the upcoming classes. But for now, you can play with the gravity. Lower the number, interesting simulation effect you will get. We have two objects, pink and green. Both are rigid body and set to active. When simulation is played, then both objects fall individually. If we want to link each other in such a way that they must fall connected. So, select the first object, click on the rigid body constraint. From here, select fixed constraint. In fixed constraint, three options: setting, object, and iteration. In object, we need to select the two objects. First pink color, second green color. Now both the objects fall like they are connected to each other, and you can see an imaginary dotted line connected to each other. Next, we can adjust some settings. Enable or disable the fixed function, and also we can keyframe it. Disable collision. When two objects fall and break the link, then both objects pass through each other. Deselect it, then both objects will collide. Breakable. When both objects fall, the fixed link always stay connected. If you want that the selected link to be break, click on breakable option and reduce threshold value to minimum. This link will break as soon as it collides with another obstacle. Last is the override iteration. This value decides the best calculation to get the better result. Let's have a quick setup. On the viewport, three objects present: a door with a frame and one cube. First, set the origin of the door to the other end, near to the frame, so that when you press R and Z, its rotation will be on the Z axis. Also set the frame origin to the same point. Select the door, add a rigid body to active and enable dynamic deactivation, so that door should be at one place. Then select the frame, add rigid body to passive, because we do not want any movement on the frame, so it is passive. Now hinge setup. Select the door, add the rigid body constraint, click on hinge. Now you will have the same similar setting just seen in the fixed constraint. Here also we need to select the two objects. So first select the door, second frame, and done. Finally, select the cube, set a rigid body to active and enable animated. Then just keyframe it so that it passes through the door. After playing the simulation, it works. The door opens when some rigid body come in contact. But the door is opening and rotation in the endless limit. We can limit its angular momentum. Just look at the rigid body constraint menu. Click the limit, then in angular, enable Z angle and set the lower and upper limit something like -60 and 60 degree. Again play the simulation. Now this time more natural result you will get. So this was the basic function of the hinge constraint. Now if you wish that this door must be open in such a way, then using empty as a hinge constraint also be useful. Both cylinder and the door is set to rigid body, one passive and door to active. Now add a empty, set axis to the Z direction. Then select empty, add rigid body constraint and select hinge. Then select door as the first object and second cylinder. Now play the animation. It will work perfectly. The basic mechanism of the slider define an object slide in the range with reference to other object. To use the slider, we need two objects. First, a rectangular object as a slider and cube as a rigid body. Select the cube, add a rigid body to active, set animated. Then select the rectangle slider, add rigid body to active. Finally, add empty in the between both the object and set the axis perpendicular to both objects. Select empty, add rigid body constraint and select the slider. In first object, select slider. Second, select cube. In the limit, enable x-axis. Set lower and upper limit. Now play the animation. If you move the cube on x-axis, then the slider move up and down with the limit difference of 1 meter. Let's have another example which perfectly defines the slider function. You can use this setting shown on the image to create a slider movement. The two objects on the viewport with a rigid body applied. Select both the cube, go to the object in the rigid body submenu, click on connect. It will add empty with a rigid body constraint. Just change the type to the generic spring. Play the animation, the cube will fall with an imaginary line connected to the first cube. It does not behave like a spring, so we need to enable some setting. Select empty, go to the rigid body constraint. You will see 4 different functions: limit, angular and linear, and also spring, which we can control. Expand all this, then enable everything. Now press space button. This time the cube falls but appears like a spring connected to it. Now first is the limit, angular and linear. In angular, we can limit the angular moment of the object in terms of degree on every axis. By default, it is 45 degree, so simulation of an object angular moment will be within this range. Let's make x and y axis angular limit to 0 and then z to the minus 20 and 20 degree. Now you will see that the object moment to the only z axis and x, y are restricted. Similarly, linear limit work. We can limit how far an object can move in a linear direction to the axis. Let's set x and z axis to 0 and y axis to minus 4 and 4 meter maximum. Then the result, the object can travel up to 4 meter on the y axis. Last and very important, spring. Here also the same linear and angular limit is given, but in terms of stiffness and damping. Stiffness and damping are the physical property of the spring. By default, stiffness is 10 and damping is 0.5. Adjusting both the value decide how strong or smooth working of a spring to the gravity or force applied. And also, it's mainly depend on the weight of the object. More the weight, then the object will fall linearly down moment length. How to set up a motor constraint on an object. First, the body. Second, fan. Both are rigid body applied with a body passive and fan active. A empty hinge applied in order to keep the setup at one place. Then another empty was added with a rigid body constraint and motor selected. Keep a note that the hinge body and the fan axis must be in the same direction. It shows z-axis in this example. Now selecting the empty motor constraint, enable angular. Then press space button, motor will start rotating with the angular velocity. And adjusting the target velocity and impulse value, you can set minimum or maximum speed of the motor. We can add physics to the car, which includes spring and motor with the main function. In this example, we have a car on the viewport, divided into 3 parts: the upper main body, base body, and the wheels. Just keep them in a separate collection. Base and the wheel applied a rigid body and set to active. First, we will set a generic spring. Add a empty, select type to generic spring. Then select first object as the base body and second the wheel. Now check the limit, which includes angular and linear. Practically, wheel angular movement is on z-axis. So let's set it -20° and 20° maximum. X and Y angular movement is not required, so set it 0. The linear, select all X, Y and Z and set it to 0. Linear at present is optional. Last, the spring setting. Spring mechanism required on the downward, that is on the z-axis. So enable the z-axis in the linear and rest keep it deselected. Then copy the wheel to the rest of the 3 positions. Finally, play the simulation. Base body and the wheel perfectly respect the generic spring function. You can achieve more variation by adjusting the damping and the stiffness value. Now, if you keep an inclined surface with some hurdle on the road, the car assembly will react to it, but the wheel movement is not sufficient or natural. So, we need to add a motor constraint. To add a motor, insert a sphere empty. Reposition to tire, then rigid body constraint, select motor. Select the first object as a base body and second wheel. Then enable angular movement, enter any value. Copy the same sphere to the another tire and also select the object and the wheel in the second constraint. And done. Now play the simulation. This time car due to motor constraint enable cross the hurdle with a good velocity.